speaking solution, answer to your question. But practically speaking, you all know deep learning is not something that can be explained very well. So we have to do experiments. So we have done experiments, and we found that max boolean is the best. So I wouldn't say it's optimal, because I mean, if I have infinite amount of GPUs, I can do it. I can say it's optimal. But since this is what we can do, and we found max boolean can do the best. So.
Oh, I see. Thank you.
Okay. If there are no questions, thank you very much again.
Thank you.
And now let's move on to the last speaker. Basically, the title of the paper is SoccerNet-Echoes, a soccer game audio commentary dataset. And yeah.
Hi, can you hear me?
Yes, we can.
Okay, can you see me?
Yes, we can.
And my screen as well. Yeah, perfect.
Yes, of course.
Okay. Let me. Okay. Should be good. Yeah. Good evening, everyone. Nice to see a lot of good presentations and very informative keynotes. A short introduction about myself. My name is Sushant Gautam. I am a second-year PhD student at Simula Metropolitan Center for Digital Engineering here in Oslo, Norway. And I work around soccer or football game understanding. So today I am here to present our paper, SoccerNet-Echoes, a soccer game audio commentary dataset. This particular work represents a significant advancement in sport analytics, enabling the integration of audio, visual, and these new textual modalities for a deeper understanding of soccer games. So sport analytics have made significant stride over the years, transitioning from computer vision like visual analysis to more sophisticated multimodal approaches. Traditionally, soccer analytics really on computer vision back then. We were trying to do action spotting, player tracking, fall recognition, and so on. But we realized that there was much untapped potential in the audio and textual data accompanying these visuals. So the story begins with the SoccerNet dataset. In CB Sports 2018, there was this new dataset introduced. It was called SoccerNet, and it was a cornerstone in soccer video understanding with challenges like action spotting and replay grounding. So I think I can give a short preview here. Yeah. So this is the SoccerNet dataset. So they come up with challenges each year. So they have different tasks, like you can see here: action spotting, ball action spotting, replay grounding, tracking, re-identification, and so on. These are all the tasks that are related to soccer video understanding. And they have this data set of 550 broadcast soccer game videos taken from a single camera. So it's a broadcast video that we can see on our television. So this is the data set that we are using in this particular research. So today I'm excited to present SoccerNet-Echoes because this data set, it leverages ASR, or automated speech recognition technology, to bring audio commentaries into fold, enhancing soccer analytics like never done before. So our contribution with this SoccerNet-Echoes dataset are threefold. First, we have augmented the existing SoccerNet dataset, that is the dataset with videos, by incorporating multilingual audio commentary transcriptions and translations, providing a robust dataset for researchers. Secondly, we evaluated those ASR technology across multiple Whisper models. So these Whisper are models from this company called OpenAI, very popular now, that makes ChatGPT. And we try to make sure that they are of good quality and they are reliable. Lastly, we demonstrated applications of this dataset in multimodal event detection and game summarization, showing how it transforms traditional analysis into a richer, more context-aware process. So, like I mentioned before, the SoccerNet dataset, it comprises of 1,100 half-game videos, or like 550 matches, and it spans across six leagues, as you can see here on the picture. It's EPL, UCL, and so on. And also, there are 10 different languages in the commentary. This is in the original dataset. And as you might have noticed here, there are 70 games or 70 game apps that doesn't have any language in the audio. So we are transcribing this dataset. So these are the different variations of languages in the English. So there are lots of languages here, 10 different languages. So for non-English language, we use Google Translate to translate this different language into English to use it in different downstream application. So the dataset is now available to the community as an open resource, enabling a wide range of research application and sport analytics. It's in GitHub. Maybe I can give a short preview here. So it's public, as you can see. So it's structured like this. So there are different Whisper versions. So we have used 3 different versions, and there are different leagues here, different games. So for each game here, we have first half and second half. So for each half, we have annotations separated by half like this. So this is the format that we have here. And we can also explore this on Hugging Face. It's very easy to use this from Hugging Face just to have a preview. For example, yeah, these are different subsets. You can explore it from here. For example, let's check the one in version 2. So here we have 2 split, one in original language. For example, you can see this text. These are not in English, should be in Spanish, I guess. And we have translated this using Google Translate to English. So if you see this subset, it's going to be in English. Yeah. So these are the timestamps of the videos in the dataset. So there are 550 full game videos, and for all those videos, we came up with text of the commentary that is spoken in the video. So this is what we have basically done for dataset curation. Okay, now let me go back to the presentation here. So as I mentioned, we have used 3 different Whisper versions. So it has been 3 different iterations from the company. So it's called Whisper Large B1, Large B2, and Large B3. It's the bigger model. There is also Turbo, but yeah, when we did experiments, there was just these 3 to transcribe the soccer commentaries. And language detection was done through Google Translate. So we first get the commentary, get the transcriptions, and we check whether it is in English or not using Google Translate. And if it is in English, we just leave it like this. And if it is not in English, we translate those into English. So to make sure that everything is in English, so that it can be used in some downstream applications. However, we got challenges like hallucinations. So it's a big challenge in this LLM domain now. So it's like unwanted phrase repetitions. So for example, if there is some event like goal and there is some noise, the model will always like give us goal kind of stuff. So it is unwanted repetitions, and also inaccuracies in noisy environment. If there is some cheering going up in the stadium, so the model will give very inaccurate transcriptions. But despite these limitations, this model's performance across multiple languages has been remarkable, as you will see in the evaluation metrics. So this is usable for different applications. Evaluating model has always been challenged. So for this evaluation of the Whisper model, we compared their performance using different metrics. These are classical NLP metrics, I would say, like word error rate, WER, character error rate, CER, and blue score. So there was this data set called Goal. So luckily, like it was just published while we were doing this, and they have transcribed 20 videos out of 550. And they chose videos that were of high quality and that were in English, and they had just published it. So we took that dataset as reference dataset or gold dataset. So we used that as reference dataset and evaluated the output of our Whisper model with that dataset, because it was manually human corrected. So they figure out mistakes there. They have also used some ASR system, but they manually corrected the problems they had in the dataset. So that could be a good candidate for the gold dataset for comparison, comparing our output from this Whisper model. So as you can see here in the table, we have the scores for different models, but surprisingly, we got better scores in Whisper Large B1. Out of three model, all the scores were kind of almost all are lower in are better in V1 model, but that shouldn't be so, because newer models should always be better. So that's what it's supposed to be. But on the deeper analysis, we figure out that the latest model, that is Whisper V3, it was better in linguistic richness and diversity, and we came up with some idea to figure out best transcription among these 3 models, and we used unique word metric. So we tried to figure out how many different unique word all these 3 models they were outputting. So using that metric, we figure out that Whisper V3 it was richer in linguistics output, and it was selected as best model in the analysis. So you will see the output from different model. The first one is from the gold dataset. So this is a visual distribution of noun verb pair. So in the first circle, you can see nouns, different nouns in the transcription, and the outer circle is Bob. So the association of this. So in the first one, this is from the standard dataset. The second one is from Whisper version 1, and the last one is from Whisper version 2. So as you might have seen, different. It's quite denser than V2. So upon visual inspection, we saw that large V3 was outputting lots of different richer linguistics keywords. So this would be better. And also we did some manual verifications, and definitely like the output from large V3 was fine, although the classical metrics show that V1 was better. So now here I mentioned the way that we selected best model. So we try to see like how many best model were selected out of these three. So when we used this metric, large B1 was selected almost like 31% of time, and large B2 was selected 31% of time. Large B3 was selected 37% of time. So when we it's the mixed selection. This is the sum of all these things. It's the same thing, but yeah, I mean, this is the pie chart you can see. So almost like 50% of the time, large V3 model was the best out of all these three using the unique word metric that we derived. Now, SoccerNet-Echo, it's a game changer for two key applications. The first is event detection, and the second is game summarization. So here I have classification report for event detection. Here we use this dataset to do classification of 8 different events as listed here. So we have different modalities at input. It could be combination of audio, video, and the ASR that we derived. And we trained a model and we evaluated it on a classification validation set. So these are the scores on the validation set. So as you can see here, the scores are pretty good. So it's almost around 70%, around 72%. So this shows that the model that we get using this ASR, it's quite better. Now, we do some ablation study here to see what is the effect of combining different modalities and how much contribution does ASR actually have. So these are the different classifiers that we train. These are the different variants. So the first one is like using all the three as input. So we have audio, video, and text as input, and we pass them into feature extractor, and we kind of merge these features, and we try to classify either those features are of which class, and we try to quantify it with this F1 scores, and we see that when we use all the features, the score are pretty high, but it is not that much higher than what we get with just audio and video. So the contribution of text is quite minimal here. So also in the bottom, you can see that if you only use text, the contribution is very small. It is not so significant. It is the lowest of all. But if we combine video with text, as you can see here, it is almost around like combining audio with video. That means like we can replace the audio stream with just text. And if we use text, it is very easy to explain what was the reason that the output of classifier is high, because it is in the form that we can easily read and it's kind of explainable. So it helps in explainability instead of using audio signal. Audio signal is very difficult to analyze because when we use feature extractor, it gets into hyper domain. So it's very difficult to classify. But when we use this modality with the combination of video and text, it becomes quite explainable with almost similar F1 score. So this is the finding that we have reported in the paper. So for another task, it's summarization. So we try to summarize the game with two different modality. So here are three different violin plots. The first one is Rouge-1 score. The second one is Rouge-L score. The third one is Bot score. For each violin plot, we have like two different modality. In the first one, we are using event. When we give event as input and all the information of event, and we train a classifier, we train a summarizer, so it's going to give some summary. So in the second case, we have ASR. ASR is the output from our system. So we use these transcriptions and we try to generate summary. So we compare the summary of two different modalities here, and we see that the output from ASR, it gives better summary than the event information itself. It is quite intuitive, but yeah, this proves that using ASR, it helps us to get immense value of integrating ASR sports into sport analytics for summarization. So this figure shows our multimodal pipeline for generating SoccerNet-Echoes dataset. So commentaries are first transcribed using Whisper and then translated into English. Then we kind of also try to validate games with audio or not. So we try to see if audios are really there and if it is giving good alignment of the of mapping commentary segments to video events. For example, like if there is some event here in 30-minute 10-second fall, so this is what we have in the original dataset. So we only have event information. So somebody have annotated that it's just fall there. But when we use ASR, there will be a lot of like sentences that will describe this particular event. So at similar time, we'll have the words spoken by commentator. So we'll have a lot more information than that would be just in this particular event information. So this is what I want to show. So now using NLP techniques, we analyze these recurring patterns. So we want to see like what this graph contributed here. So we figure out that this dependency parsing and constructing these verb noun pairs, it helps us to figure out different dominant pairs that would be used in the soccer game. For example, we can see that there are words like save penalty, and there are words like give offside. So these are recursively used along all the things. So this helps to see like what kind of words we use, and this figure highlights these combinations, offering insight into player dynamics and the narrative style of commentators. So yeah, we can also compare this across different commentators. So they might have different styles. So this kind of help to analyze that as well. So multimodal analysis brings unparalleled contextual awareness by combining video, audio, and text. We can see that improved accuracy and also explainability in tasks like event detection and game video understanding. So I'm going to show how this dataset contributes into game video understanding. So with a short demo here. So this is the application that I'm currently working on, and I have used the dataset, SoccerNet-Echoes dataset, to come up with this stuff. So it's okay. Let me have some architecture here. Okay, I have borrowed this from video ChatGPT paper, so it's very similar. So we have a video, we pass it to some feature extractor, and we have some query here. For example, like where is this video taken from, and we pass it to language model. So we expect this language model to give us some output. So we have video, we pass it to clip model, it's a feature extractor, and we ask a question about this video, and we expect this model to give us some answer. So it's basically video understanding. So it should be able to answer our questions. So we want to see how our data set helps us to understand video. So I'm gonna show it from this demo as well. Okay, let me more. Let's make it static. Yeah, this one. So to train this kind of model for video understanding, we need questions and answers. So these are basically text. So we have lots of videos from the original dataset itself. So what we want here is like questions and answers. So we use this SoccerNet-Echoes dataset to generate these questions and answers, because we have lots of text. It is not so difficult to transform those information in the dataset in textual form into question and answers. For example, if there is some information like, okay, Messi was going to hit a goal and he scored. If there is this text, we're going to change it into question. What was happened in the video? And the answer is going to be, yeah, Messi just scored a goal kind of stuff. So yeah, this is what we do here. And using this, we train this model, we train this linear model, linear layer, and we try to map this video into this large language model so that we can ask questions here and get some answers. And this is the output here. For example, this is the UI that I built to showcase this. So we have the train model. I'm gonna load some random video, and okay, this is a random video. So we ask some questions. So you can ask whatever you like, but I'm gonna ask about what action is shown in the video. Okay, let's make it wild and just ask it. So it's gonna take a few seconds. Yeah. So this is the video. You can see here, something is happening. Okay, he's gonna, yeah, goalkeeper stepped the ball, and yeah, this is something. This is a very short video, so we want it to understand. So so we can see that this is what the model saw. So it says that the video captures the moment of the player from the blue-white striped jersey team take an indirect free kick, aiming to create a scoring opportunity for their team. So yeah, this is exactly what happened here, because yeah, somebody from the blue jersey team, they kicked the ball. It was free kick, and like they tried to score the ball, but yeah, it was just an opportunity. There was no goal. So this is what the model say. So yeah, you can. This tool is like it's online now. So if you want to check, I might share a QR here. There is some. Yeah, I don't know how many people are there in the audience. I can see you guys, but yeah, if you want to try this demo, you can just scan this QR, and you can just click this load another random video. So there are like thousands of videos randomly loaded, and you can have a chat with this model. So you can ask what you see, like you can ask like what it sees there, and like that you can chat similarly like you chat with ChatGPT. So like this is a video understanding model. So it's a BLM trained on synthetic dataset created using our SoccerNet-Echoes dataset. So it's a very beautiful application that this dataset can curate. Okay, let me go back to my presentation. Yeah. So as a broader application, we can more accurately detect event, generate summary, and even perform even sentiment analysis or tactical assessment. So this dataset empowers researchers to explore these new dimensions. While ASR technology have come a long way, there are lots of challenges. There are problems with background noises, overlapping speeches, and translation inaccuracies that can affect the quality of transcriptions and the performance in downstream tracks. So we need manual verifications. So we are very lazy because it takes a lot of time and a lot of manpower and even like funding to do that. And there could be some advanced pre-processing technique that could overcome this issue. But yeah, this could be good future work. And these limitations are a call to action for improving this dataset reliability and quality. So maybe with collaboration with community source annotations. So the potential of ASR extends far beyond soccer. For example, instruction video captioning, this kind of work have been done. So we can see papers and researches in this direction. Also, like there was a recent paper with cricket analysis using ASR, so similar to the thing that we are doing. So by leveraging this technology in different domains, we can make content more accessible and insightful for a broader audience, because it is very cheap to do ASR. So these models have been democratized. So it can be used in different applications, and it can be used for different content recommendation and narrative generations and so on. So in conclusion, SoccerNet-Echoes advances sport analytics by integrating ASR-based textual data with video and audio. So this multimodal dataset enriches soccer analysis, enabling more accurate event detection and detailed summaries, and also video understanding, like you saw in the chat UI. And it is a step toward holistic sport research and immersive fan engagement. So it can help to create these things. So we invite you to explore SoccerNet-Echo and contribute to this evolving field with different applications. So the dataset and associated resources are freely available through GitHub. So you can scan this QR to get into the repo, or you can find it in official SoccerNet GitHub repo. So we encourage researchers to explore its potential into mostly multimodal learning. So how we can fuse this new modality into what we already have, and we can push the boundaries of sport analytics and create some groundbreaking applications maybe. Special thanks to SoccerNet Challenge community for this dataset. So it takes really hard time to curate this dataset and make it open source. So yeah, some words for them. So before we wrap up, I would like to express my heartfelt thanks to organizers for accommodating my remote participation. I regret not being there to join with you in Japan, and I truly appreciate the opportunity to present this work to such an esteemed audience. And I look forward to engaging further with the community, even it's from distance. So you can find me on LinkedIn or through the email. Now I would be happy to take any questions. Thank you for your attention.
Thank you very much. Now I will invite the opponent to the line. So just you have 5 minutes to present your concept.
Hi, can you hear me?
Yeah. Hi.
Okay, is it okay if I share my screen?
Oh yeah, I should stop it. Okay, well, let me see. Yeah, perfect. Yeah.
Okay, just a second. Okay. So I'm Carla. I'm from Brazil. I'm an intern at the Institute of Science and Technology, and I'll be commenting SoccerNet-Echoes, a game audio commentary dataset. This article, explaining briefly what it's about, you just did, but this article explains how the authors added ASR technology, to the SoccerNet dataset, and then created SoccerNet-Echoes, a version that can transcribe and translate the soccer game's commentaries. It shows improvements in multimodal game detection and game summarization, and it makes relevant advances in sports research and analysis. Here's a picture of how it works, a figure that represents how it works. It transcribes the audio, and then using OpenAI's Whisper, then Google Translate detects which language its transcription is in. If it's not English, it translates it to English. And they also validated games with no commentary, right? There were about 70 games that had no commentary. Okay, about their contributions. SoccerNet-Echoes augments the SoccerNet dataset with ASR that transcribes and translates the commentary from multiple language as an open access resource. The evaluation of SoccerNet-Echoes using human verified ASR from literature and performance of quantitative analysis using these rates or word error rate, character error, bilingual evaluation understudy, and word count. And then explored the applications of SoccerNet-Echoes in various research areas and highlighted the broader implications of adopting a multimodal approach for sports research in general. These results, they show, they predominantly present action and showcase vocabulary diversity that can guide to improvement in automated commentary systems and narrative styles. Okay. The strong points were that SoccerNet-Echoes transcribes and translates the commentary from multiple languages. And it also uses audio cues to detect important events from each game. For example, the crowd's noise and the commentator's excitement. I thought that was really interesting how the AI can detect that and point out these events as it's not possible to as that's not possible easily only using video and video and text. But adding ASR to that makes it more interesting, and that leads me to the second strong point, that SoccerNet-Echoes adds ASR that enhances large language models performance, and it provides more accurate and comprehensive summaries, giving more context that lead to more nuance and details than the ones based solely on textual information. Yeah. The weak points. The first one is actually more of a recommendation and a question. Could SoccerNet-Echoes be tested on live soccer games? The soccer chat, right, that you just showed us the model, could it be used to transcribe soccer games in multiple languages and generating captions in real time? And because I know the point is using images and video from the data set, but that expands my question to, could it be used live? And yeah. And the second point is, for Google Translate to work properly, it needs concise phrases that leave no room for interpretation whatsoever. This is one of the limitations. You wrote it, that batch translations using Google Translate is not always reliable, depending on that. And I put that as a weak point. For example, I used this Brazilian expression in football that means the goalkeeper has hands like lettuce, roughly translating it, when the other team scores a goal that the goalkeeper could have stopped. And translating it word by word, that's what it means, but it just means that the goalkeeper has butterfingers. And so it leads me to the question, why did you use Google Translate? And yeah, thanks. That's the presentation. And thank you for the opportunity to be here.
Okay, thank you very much. Any question from the audience? Question? Actually, I will ask a quick question. Basically, yeah, sure. Thank you. No, because okay. I will pick first question that the opponent has pointed out. Basically, one related to the live translation over different languages. How would you pick this?
Yeah, the translation model that we use is not our novelty here, because just for translation, it can be done with like OpenAI's Whisper now. Like it's we are living in 2020, almost 2025 now, and like this technology has become so much popular, and like it has been so much scalable and so much efficient that live translations can be done as of now. So yeah, you might have tried in your phone as well. Like it can translate as you speak now. So yeah. But it's not our contribution. So yeah, I mean, this can be done easily with these technologies now. Yeah, but yeah, does that make sense? Or I didn't get it properly.
Okay, thank you very much again.
Yeah.
Now, I think